Continuing the story from our previous video about Earth's life in a day. At 10:20 a.m. on Earth's clock, about 540 million years ago, the Cambrian explosion began. In what seemed like a geological instant, life burst forth in dazzling variety. Oceans that once held only simple creatures suddenly teemed with countless new forms, from soft-bodied organisms to hard-shelled animals like trilobites. Almost every major group of animals we know today can trace its origins back to this extraordinary bloom of life. With the ozone layer now shielding Earth from the sun's deadly ultraviolet rays, life was no longer confined to the ocean's depths. For the first time, cells could survive near the surface, and eventually, even venture onto land. This protection set the stage for one of the most extraordinary events in the history of our planet, the Cambrian explosion. In a span of just a few million years, the blink of an eye on geological timescales, life diversified at an unprecedented pace. Countless new forms appeared, filling the seas with a dazzling variety of shapes and strategies for survival. Almost all the major animal groups we know today trace their origins back to this time. Biologists often call it the dawn of complex life. Perhaps the most iconic of these early creatures was the trilobite, armored, many-eyed, and scuffling across the seafloor like an alien visitor. They were among the first animals to bear hard shells, an evolutionary leap that offered protection and gave us some of the earliest fossils. Alongside them swam a bewildering cast of worms, spiny predators, and filter feeders, each carving out a new ecological niche in Earth's oceans. This explosion of diversity did not happen in isolation. Continents were shifting again, forming the supercontinent Pannotia around 600 million years ago before it quickly fragmented, reshaping the shallow seas where early animals thrived. Oxygen levels in the oceans rose. Energy flowed more efficiently through ecosystems, and with it came competition. Predator against prey, armor against claw, speed against stealth. Life was innovating at a breathtaking rate. At 10:50 a.m. on Earth's clock, about 440 million years ago, our planet faced the first great mass extinction event, the Ordovician-Silurian extinction event. Life, which had only recently flourished in the seas, was struck down on a devastating scale. Near the end of the Ordovician period, dramatic shifts shook the planet. A series of ice ages swept across the globe. Massive glaciers formed, trapping huge amounts of water and lowering sea levels. Shallow oceans, once cradles of thriving marine ecosystems, drained away, leaving countless creatures stranded. For over 1 million years, the planet froze and thawed, climates shifted wildly, and ecosystems collapsed. When the crisis was over, around 85% of marine species had vanished. It was the first great mass extinction in Earth's history. Yet, even in catastrophe, the seeds of resilience were planted. The survivors, hardy fish, stubborn trilobites, and resilient mollusks, would carry life forward. From their struggle came the foundation for new ecosystems, new predators, and new innovations. It was the first reminder in Earth's story that life's progress is never steady. It surges forward, but it can also be brutally cut back. Earth had revealed its pattern: creation and destruction, extinction and renewal. And with each cycle, life grew more complex, more diverse, more extraordinary. At 11 a.m. on Earth's clock, about 365 million years ago, the planet experienced its second great mass extinction. As the Devonian age unfolded, the seas teemed with armored fish, early sharks, and the ancestors of modern amphibians who dared to creep onto land. But the land itself was undergoing its own quiet revolution. For the first time in Earth's history, plants rose from the soil in towering forests. In the early Devonian age, they were no taller than your knee, about 30 centimeters. But by the end of the period, some trees stretched to 30 meters, rising like giants where once there had been only moss and lichens. This dramatic leap was made possible by the evolution of vascular tissue, a system of internal plumbing that carried water and nutrients throughout the plant. With this innovation, plants grew taller, sturdier, and spread across vast landscapes. But their success carried consequences. As roots dug deep into bedrock, they cracked stone and released nutrients into rivers and seas. These nutrient floods fueled massive algal blooms, which in turn robbed the oceans of oxygen. Life beneath the waves suffocated, coral reefs collapsed, fish and invertebrates dwindled, and in total, an estimated 82% of marine species vanished. Meanwhile, all that photosynthesis by the sprawling forests had pulled huge amounts of carbon dioxide out of the air, tipping Earth's climate into crisis. With less greenhouse gas to trap heat, global temperatures plummeted. Ice sheets spread once more, locking Earth in another long chill, a period scientists call the Karoo Ice Age, or more familiarly, the Ice Age. Ironically, the very plants that reshaped the atmosphere were also trapped by it. Many were buried under layers of rock and ice, their remains slowly transforming into the coal and oil that humans would one day mine. This link isn't certain, but the coincidence is striking. The forests that brought about one of Earth's great extinctions may also have left behind the fossil fuels that power our civilization. The Devonian extinction was not a sudden catastrophe like an asteroid impact. Instead, it stretched over nearly 20 million years, wave after wave of decline. It is one of the great mysteries of paleontology. But one thing is clear. By the end of the Devonian, Earth had entered a new, colder world, and life would never be the same again. At 11:15 a.m. on Earth's clock, about 250 million years ago, the planet faced its third great mass extinction, the Permian-Triassic extinction. By the end of the Permian, Earth was dominated by its last great supercontinent, Pangaea. All the world's landmasses were fused together into one colossal expanse, stretching from pole to pole. In time, over the next 100 to 200 million years, this giant would fracture into the continents we recognize today. And far in the future, perhaps 250 million years from now, scientists predict the continent will once again drift back together, forming a new Super Pangaea. But during this chapter of Earth's history, tragedy struck. The planet endured the largest mass extinction ever recorded. The Permian-Triassic extinction, grimly nicknamed the Great Dying. It was devastation on an unimaginable scale. Around 70% of land-dwelling vertebrates and up to 96% of marine species vanished. Even insects, usually resilient survivors, suffered their only known mass extinction. What could cause such destruction? Evidence points to cataclysmic volcanic eruptions in what is now Siberia and southwestern China. These weren't ordinary eruptions, but floods of lava that spilled across vast landscapes for hundreds of thousands of years. Some scientists even suspect an asteroid strike into the ocean might have triggered or worsened the catastrophe. The consequences were apocalyptic. Lava flows ignited forests, burning away nearly half of Earth's plants. Oxygen levels plummeted, likely dropping below 10% of the atmosphere. To put that in perspective, today's sea level air contains about 21% oxygen. Even the thin air atop the Tibetan Plateau, where it hovers near 16%, feels suffocating to us. Imagine living in a world where oxygen was nearly cut in half. Breathing itself would have been a daily struggle. Meanwhile, volcanic gases poured into the sky. Carbon dioxide thickened the greenhouse effect. Ash clouds blocked out sunlight. Photosynthesis faltered, and acid rain poisoned the land and seas. For millions of years, Earth resembled a hellscape. Darkened skies, poisoned oceans, forests gone silent. Roughly 95% of all species were lost, leaving behind barren ecosystems and long stretches of the fossil record with nothing new to show. And yet, life did not vanish entirely. Some creatures clung on in the shadows. Among them, the humble cockroach, whose hardy fossils never disappeared. These survivors set the stage for the next act of evolution. The Earth had been scoured nearly clean, but it was ready to be rewritten. At 11:20 a.m. on Earth's clock, about 240 million years ago, from the ashes of the Great Dying, new life slowly rose. Among the survivors of the desolate world were the first dinosaurs. Small, nimble reptiles that hardly hinted at the titans they would one day become. Over the next 170 million years, they would reign as Earth's undisputed rulers. But their road to dominance was not without peril. Around 200 million years ago, Earth was struck by yet another catastrophe, the Triassic-Jurassic extinction event, the fourth great mass extinction in the planet's history. This disaster erased at least half of all species, devastating both land and sea. The cause? A deadly cocktail that echoed the calamity before. Massive volcanic eruptions and possibly another asteroid impact. Lava and ash poured across vast regions, while immense amounts of carbon dioxide surged into the atmosphere. But unlike the drawn-out inferno of the Permian extinction, this crisis was swift, unfolding in less than 10,000 years. The aftermath was brutal. Many of the great amphibians that had once dominated rivers and swamps perished forever. Yet their extinction opened vast ecological niches, creating the perfect opportunity for dinosaurs to rise. And rise they did. By 200 million years ago, dinosaurs were no longer just survivors. They had become the masters of Earth's ecosystems. On land, they grew in size, diversity, and power, outcompeting nearly every other vertebrate. Mammals, though already split from their reptilian cousins, remained small and unobtrusive, mouse-like creatures scurrying in the shadows, waiting their turn. Meanwhile, Earth itself was changing. The mighty supercontinent Pangaea began to fracture. Around 100 million years ago, it split into two massive landmasses, Laurasia in the north and Gondwana in the south. Over the next 150 million years, this slow continental drift would shape the map of the modern world. Amid these shifting lands, dinosaurs flourished, and they were not alone in transforming. Around 150 million years ago, an extraordinary creature took flight. The Archaeopteryx, long celebrated as the first bird, with feathered wings bridging the divide between reptile and bird. It symbolized a new evolutionary chapter. The stage was set. The Jurassic world had begun, a world where giants roamed the forest and skies, and where life itself seemed to grow more daring with each passing age. With the world reshaped and their rivals gone, dinosaurs flourished like never before. The Jurassic period, beginning around 201 million years ago, was their age of triumph, a time when Earth became a kingdom of giants. Across the vast fern-filled plains and dense conifer forests, herds of sauropods thundered by. These long-necked behemoths, creatures like Brachiosaurus and Diplodocus, stretched over 25 meters long, towering like moving mountains. They swept their heads through treetops, stripping leaves in great swaths, while their colossal footsteps left trails that reshaped the land itself. But where there were giants, there were also hunters. Sleek, razor-toothed predators like Allosaurus prowled the forest and plains. Working in packs, they could bring down prey many times their size, turning the Jurassic world into a constant dance of survival. Above, the skies came alive with new masters. The Pterosaurus. With wingspans rivaling modern planes, some soared over oceans while others skimmed across lagoons, snatching fish with needle-like jaws. And then there was something even more astonishing, the first true bird taking flight. Archaeopteryx, perched between two worlds, leapt into the air, hurtling the future of flight. Meanwhile, the seas were no less dramatic. The giant Ichthyosaurus swam like dolphins with the size of whales, while long-necked plesiosaurs glided gracefully, ambushing prey in coastal shallows. The oceans echoed with the songs of ancient predators, as fearsome underwater worlds rivaled those on land. And above it all, the planet itself was in motion. As Pangaea continued to break apart, oceans widened and climates diversified. The once monolithic supercontinent splintered into smaller lands, each becoming a cradle for new ecosystems and evolutionary experiments. The Jurassic was not just an age of dinosaurs. It was an age of abundance, diversity, and expansion. Life was everywhere, thriving in forms stranger and more spectacular than ever before. At 11:50 a.m. on Earth's clock, about 66 million years ago, the age of the dinosaurs came to an abrupt end. For more than 160 million years, dinosaurs had ruled the Earth. They thundered across plains, soared through the skies, and dominated the seas. But around 66 million years ago, their reign came to a sudden and cataclysmic end. It began with a visitor from the depths of space, a 10-kilometer wide asteroid. It struck the Earth with unimaginable force, slamming into what is now the Yucatan Peninsula in Mexico. The impact carved out the Chicxulub crater, a scar more than 180 kilometers wide, and unleashed devastation on a planetary scale. In an instant, firestorms swept across continents. Earthquakes rattled the globe. Tsunamis, taller than skyscrapers, roared outward from the impact site. Even worse, dust and vapor shot high into the atmosphere, creating a choking veil that blotted out the sun. Darkness fell all over the world. Photosynthesis collapsed. Plants withered. Food chains broke apart. Within a geological heartbeat, about 75% of all life on Earth vanished. The mighty non-avian dinosaurs, from towering sauropods to fierce tyrannosaurs, were wiped out. Entire lineages of reptiles, including the pterosaurs, mosasaurs, and plesiosaurs, disappeared forever. Forests fell silent, oceans emptied. It was the end of the Cretaceous period, and with it, the end of the Mesozoic era, the age of the dinosaurs. And yet, not everything perished. Some species survived. Small feathered dinosaurs, what we now call birds, endured flapping into the New World. And so did the tiny, often overlooked mammals, creatures that had spent millions of years in the shadows, scurrying beneath the feet of giants. Finally, at 11:59 and 12 seconds a.m. on Earth's clock, about 6 million years ago, humans appeared. Around 6 million years ago, in the forests and savannas of Africa, a small population of ape-like creatures split from the ancestors of modern chimpanzees and bonobos. They were our earliest relatives, the last common ancestor of humans and chimps. Soon after, one branch began experimenting with something radical: walking upright. These early hominids, like Sahelanthropus, still knuckle-walked much of the time, but step by step, they were reshaping their destiny. By 4 million years ago, humans were walking fully on 2 legs. By 3 million years ago, our ancestors were crafting the first crude stone tools, using them to smash bones and cut meat. Around 800,000 years ago, humanity tamed one of nature's greatest forces: fire. Fire meant warmth, cooked food, protection, and above all, time to think. Our brains began to grow larger, our social lives more complex. By the time of Homo erectus, our ancestors were explorers, spreading across Africa and into Eurasia. They may even have had the beginnings of language. Over hundreds of thousands of years, different human species branched out, some thriving for millennia before disappearing. By 40,000 years ago, all other species, the Neanderthals, Denisovans, and others, had vanished, leaving Homo sapiens as the last humans standing. And then, a turning point: agriculture. Around 10,000 years ago, humans began farming, trading nomadic wandering for permanent settlements. Farming provided surplus food, which in turn supported priests, rulers, and specialized workers. Humanity was no longer just surviving, it was building. By 4000 BCE, the first true civilization arose in Mesopotamia: the Sumerians. Writing, religion, monumental architecture, and cities transformed human society. Not long after, the Egyptians and Indus Valley peoples flourished. By 3000 BCE, Hinduism, the world's oldest surviving religion, had begun to take form. By 1300 BCE, writing was widespread, freeing knowledge from the fragility of memory. With literacy came education, science, and the possibility of history itself. Empires rose and fell. Around 500 BCE, great civilizations in China, India, Greece, and the Middle East built vast empires, clashed over territory, and exchanged ideas. Philosophies, religions, and sciences flourished. Humanity was no longer just a collection of tribes. It had become a global network of cultures. The centuries that followed saw new heights. The Renaissance in Europe, where art, science, and philosophy flourished, symbolized by works like Da Vinci's Vitruvian Man. Then came the Scientific Revolution and the Industrial Revolution, which transformed societies into engines of industry, progress, and population growth. In 1804, the global population reached 1 billion for the first time. By 1927, it was 2 billion. After the devastation of the 2 world wars, humanity entered the atomic age and the space age. In 1957, the Soviet Union launched Sputnik, the first artificial satellite. Soon after, Yuri Gagarin became the first human in space. By the year 2000, humans had established a permanent presence aboard the International Space Station. Now it's noon on Earth's 24-hour clock. With half a day still ahead, if we set aside the impact of humans, what might the future hold for our planet? The story of Earth isn't finished yet. Even after billions of years, its landscapes, oceans, and life forms will continue to evolve, and dramatic changes still await in the remaining hours of this cosmic day. About 4 million years from now, around 1 p.m. on our 24-hour Earth clock, all plants on Earth will die. As vegetation vanishes, carbon dioxide levels will drop drastically. Without plants, herbivores will follow, and soon after, carnivores will disappear as well. Between 1.5 and 4 billion years from now, around 2:30 to 4 p.m., Earth's core will begin to cool, and by 4 p.m., it will be completely cold. Without a molten core, the planet will lose its magnetic field. Solar winds will strip away the atmosphere, and with no air, surface life will vanish. Eventually, the oceans will evaporate. In other words, in 400 million years, the greens of Earth will fade, and in 1.5 billion years, the blues will disappear too, leaving a planet that resembles Mars. By 10:30 p.m., roughly 4 billion years from now, the Milky Way and Andromeda galaxies will collide. Massive starbursts will light up the cosmos, and supernovae will erupt continuously, bombarding the remnants of Earth with ultraviolet and cosmic radiation. By then, though, Earth will be devoid of life. Finally, 4.5 billion years from now, at midnight, the sun will expand and engulf the Earth. The blue planet that once nurtured countless forms of life will vanish from the universe forever. Today, over 8 billion people inhabit the Earth. Humanity has decoded its own genetic blueprint, reshaped life through biotechnology, and is beginning to explore other worlds. Yet, for all our progress, our time is vanishingly small. Earth is 4.5 billion years old. Life has thrived for at least 3.8 billion years. And 5 mass extinctions have come and gone. Humans, members of the animal kingdom, vertebrates, mammals, primates, and finally, Homo sapiens, have existed for only about 200,000 years. On the cosmic clock, we are but a fleeting instant before noon. The past reminds us of Earth's cycles. The third and fourth great extinctions were separated by roughly 60 million years. The fifth, the one that killed the dinosaurs, was also about 66 million years ago. If such a rhythm holds, another extinction could be due at any time. In millions of years, thousands, or perhaps even within centuries. When mass extinctions come, they do not just erase species. They can wipe out entire phyla, whole branches of life itself. If humanity were to vanish in the next extinction, perhaps a few fish would survive and flourish. In a sense, their survival would be ours too, since all vertebrates, fish, amphibians, reptiles, birds, and mammals, share a common ancestor in the phylum Chordata. But for Earth, the disappearance of humans would barely register. Within 500 years, our buildings would crumble. Within 10,000 years, only stone monuments would remain. And in 50 million years, new life would dominate the planet, studying our fossilized bones the way we marveled at dinosaurs. Whether through technology, wisdom, or luck, humanity may yet endure. We may spread beyond Earth, settling other worlds, or we may fade, leaving the planet to heal and begin anew. Either way, the story of humanity is but one chapter in Earth's vast and ancient tale, a story still being written.